Hello students, is the screen visible?
Good afternoon, sir.
Yes.
It is visible, sir.
Good afternoon, sir. Good afternoon, sir.
Okay, so we were discussing uh, this. We have completed the center of pressure and the total force in the last lecture. So in the last lecture, we have covered these forces on immersed bodies, forces on plane area. So these parts we have completed, and we have derived this expression, the total force, and then based on these concepts, we have discussed the equation for the center of pressure. Okay, okay. Including the forces on the curved surface we have. So today we will discuss the buoyancy and flotation. So maybe you are aware of this word, that is buoyancy. At least you are aware of this word. What is the buoyancy basically? So when a body is immersed, okay, either wholly or partially in a fluid, it is subjected to an upward force. So I think that we all are aware of this. And this is the reason why uh, any weight in any object, the weight of the object, okay, if you are immersing this object in a liquid, you will feel that the weight is decreases due to the buoyancy force, because when you insert this object like here, a buoyancy force acts in the upward direction. So buoyant force is always an upward direction. It always acts in the upward direction. It never acts in the downward direction. Always in the upward direction. Okay. So tendency of a immersed body to be lifted up, okay, in the fluid due to an upward force opposite to the action of gravity is known as buoyancy. So the term buoyancy means it is a tendency of a body that it is lifted up when it is immersed in liquid, and that buoyancy is actually happens against the gravity. Now why against the gravity? Because the gravity acts in the downward direction and buoyancy acts in the upward direction. This is buoyancy and this is gravity. So that's why it is said that this buoyancy act means it is due to the upward nature, it acts opposite to that action of gravity. And the force tending to lift up the body under such condition is known as buoyant force. So buoyancy is a tendency that a body is lifted up, and the amount of the force acting during that buoyancy is called the buoyant force. And this buoyancy effect is based on the Archimedes principle. What is Archimedes principle? Tells when a body is immersed in a fluid, either partially or fully, it is buoyed by or lifted up by a force which is equal to the weight of fluid displaced. So this is the important thing. Means the weight of the fluid displaced by the body, okay, be displaced by the weight of the body is equal. So that weight, okay, this is means the weight of the, if this is the weight of the object, that is object is equal to what is the weight of that fluid which is displaced by this object actually. So these two are the interrelated. This fluid is displaced by this object. Then this will be equal. So weight of the fluid displaced is equal to the weight of that. Okay, now next, what is the expression for this buoyant force? This is the expression. So to derive this or to discuss this expression, we will consider this diagram. Here you can see that we have a body of height h. Look at here. Obviously, we know that a force will act on this surface, on both the surface, like here and like here. And we have already discussed that due to this height, like in the last class, I think in the previous class, okay, means the pressure distribution inside the body, okay, which is inside the fluid like this. So this case is same. This case is same. So here, look at this. This is our weight. So this, what is the amount of this force which will act on this upper surface? So it depends on this S. Okay. So look at here. This is our expression for the force, and this is actually related to this, like P is equal to rho G H. This is our S here. This is our S here, and when you will multiply with this area, this will give you the force. So this is the force. So it is like same rho G, and at the place of H it is S. And this difference, the height difference, will give you the another pressure value at this bottom face, at the bottom surface. So look at here, what is the difference between the pressure which is acting on this surface and at the bottom surface is this. So this is the force which is acting on the bottom surface, which is differ by this amount, that is the height. Look at here. Okay, so when you will subtract this difference, it will come out with a value that is rho GH. Here H is the height of the object, into A. Ultimately, this H into A, if A is the surface area, the area of this object, and you multiply with H, it will give you the volume. So this V is actually a volume. So this is the expression for this. Okay, so this is here now. This is what we have discussed, the buoyancy. Now the flotation. So this flotation is the, you can say basically a special case. What is that special case? When only a portion of a body, look at here, means you can say partially submerged body. So when your body is partially submerged inside the fluid and the remainder poking up out of the free surface. So you can see here, this part is out of the surface. Okay, so this is a case of floating bodies. Floating bodies. Okay, so this is your floating body. Now let's discuss some more about this, when it will be submerged, when it will be floating case. Okay, so I think you can experience this in your practical life. Okay, that a body actually submerged completely inside the body, and it can reach to the bottom of the fluid when the density of the object. Okay, here rho is actually the density of object, and rho F is the density of fluid. So here, this is the case when the density of this object is larger than the fluid, and this is the case when density of fluid is lower than the density of the object. Sorry, higher than the density of the object. And this is the suspended case. You can observe such type of situation also when a body is feel like this suspended inside the fluid. So this happens when this density is equal to the density of object is equal to the density of the fluid, like this. Then you will find that the body is suspending. It is neither going down, neither going up out of the surface. It will suspend. So this happens in this case. So these are the three cases. Means this is the submerged, like the suspended. Means this is like you can say this is sinking body, not the submerged. This you can call the submerged type. Okay, this is and then this is sinking, which will completely reach to the lower surface, bottom surface. So these are the three cases in this. Now then comes the stability case, the stability of a submerged body and stability of a floating bodies. So when a submerged body will be in a stable condition. So first of all, what is the stable condition first? What is means what is the stable and unstable and the neutral like this? For understanding
Sir,
of
in the
this, let us,
stable condition,
hello,
yes.
you are saying something?
Yes, sir. Sir, in stable condition, the net force and the net torque is zero. And if we rotate it a little, then it will return back to that stable position. But in unstable position, the net force is and the net torque is zero. But if we slightly displace it, then it will return to the stable point.
Okay,
And in neutral,
okay, good. You are aware of this, but I think there are other students who may be not aware of this topic, basically the concepts is the stability. Okay, so now to understand this stability condition here, I have taken a convex surface, and this is the convex surface, and this is a plane horizontal surface. Now put a ball here and one here, and apply a force here. Apply a force here for this ball also. Okay, for this ball also, and here we have. Now what will happen here? Who will tell? Who will answer? What will happen? If you
That
are
small, if we apply in the above one, it
this
will go
this
down
form,
and tangentially fall, and if
yes,
we will apply on the below one, it will again come to the own position and it
yeah.
will
So
oscillate.
this is the case. Basically, means first of all, the physical interpretation of the stability. The physical means how physically it looks. Stability means what? Physically. जब आप आंख से देखोगे, when you will see from your eyes, how stability you can feel. The question is not mathematical. So it is like this. When you will apply a force here, it will goes down and it will never come back to this same position. But what will happen with this? When you will apply force, it will goes like this. It will come back and maybe it will goes like this also. But at last, you will find that it reach to the same position. What will happen with these? There is no such type of like oscillations. Oscillation is not possible here. It is like neutral. So this first is like unstable, and this is stable because it
Stable.
is reaching at the same position after the disturbance. So this is called the stable, but here it will never reach to a same position. And this is the neutral means like with such type of phenomena will not generate there actually. It is like the neutral type. So this is called like the neutral. So this is neutral. So there are these situations when these conditions arises in such type of bodies like submerged body. In our practical application, let us move to a practical examples, practical application of this topic. We have the ship, we have the devices which is used in the fluid, inside the fluid, and you can say like out when the some part of out of the fluid like the floating type of bodies. That's why we require sometimes that what will be the condition for the stability of such type of bodies. So for that case, we require this concept. So stability, for stability of the submerged, first of all submerged, then we will discuss stability of floating bodies. So when we will find that the buoyancy force is above the gravity force, then it is a case of stable. Now why stable? Because here you can see when you will apply some force here, let us see that you are applying a force here. Due to this force, a disturbance will come here in this body, in this is your body. Okay, due to which here a turning moment, like a turning moment will generate. This is called the turning moment. Okay, but here you can see that this buoyancy, this gravity, the center of gravity lies in a same line. But why? Because this buoyant force in a means in a static condition, like means without any disturbance. When your body is in without any disturbance, this gravity or buoyant force passes in a same line. When you are giving a disturbance, what happens that these two forces which is passing through the same line, okay, like here we have the two forces, okay, but when the disturbance comes, a distance generated between these two fluids. Look at here, this is the perpendicular distance, this is the perpendicular distance between the two forces, like here it is Z and like here it is B. So this is our perpendicular distance. And we know that this G and B will always be equal for the stability condition. Now remember the class of the couple. Remember the class of the couple when the two forces with equal magnitude having perpendicular distance can generate a couple. Okay. And due to this, a restoring torque generate there. Look at here, if your body is getting disturbed, it will rotate about some point. So let us consider that this point lies here because it will rotate like this, because it is submerged. So when we will take a hair, like the moment here, look at this. Look at this, both are giving the same direction. Look at here. So this is like due to G, this is like due to B. And this is your turning moment, which is generated due to this force. So look at here, this turning moment is in this direction and restoring is in this direction. And this is why your body is reached to the same position. Okay, so this is the concept behind why this stability. Now, what happens when there comes the instability? So in the instability case, the G goes up and buoyancy goes down. This is the condition for the means for the unstable conditions. When such condition arises, when you apply a force, the restoring torque means this is your overturning force. Okay, look at here. Now take the moment. This is your W. This is your buoyancy due to the buoyancy. So let us take that Rm is due to Gn, that is geometric, that gravity moment and the bending moment. Sorry, buoyancy moment. Okay, so here you can see this is your turning moment, and now this is your restoring moment, which is Rm due to like the Gm plus Bm. So look at this in the same direction. So in this, both are applying in the same direction, and your object may topple like this due to the overturning couple. So in this case, they are generating a overturning couple, means they are actually helping to overturn. And here in the stable case, they are opposing the turning effect. So this is the reason why the stable and unstable condition comes. Now, when this B and Z lies at the same point, then such type of disturbance will not generate a turning effect. It can like the it will like the move like this here, like the translator means it is like the neutral positions. Turning effect will not generate. So this actually this is your the case unstable, stable and neutral. Then comes a case that is the floating bodies. When the part of the body of the object, look at here, is out of the fluid, this part. So this is called the floating bodies. Now the stability problem on stability and unstability problem. In such type of bodies, floating bodies, it's somehow complex because there comes another point here which is called the metacenter. Okay, so now we are going to discuss here in this case actually. So since as the body rotates, the location of center of buoyancy actually here, what happens when the body rotates, this center of buoyancy moves like this, like B dash here, B dash. Okay, B dash is the new position of this buoyancy. So this happens. So due to this, the center of buoyancy, it always displaces due to the displacement. Okay, which due to the displacements in the body. In this case, in the floating bodies. Okay, so this is the reason which generate the complexity in such type of bodies, like in the floating bodies. Now, one of the best example of the floating body is the ship. Your ship designing is based on these metacentric concepts. For the small values of theta, first of all, what is this metacenter actually, that we will understand. Okay. So for a small values of this theta, the point M is practically constant in the position and is known as metacenter. And it is that point about which your body oscillates, your floating bodies oscillates. So that is the metacenter. And the buoyancy force always passes through this metacenter. Okay, so that is your metacenter. And this height, that GM, is your metacentric height. So during the designing of this ship, like you can take the means if you suppose you want to design any floating bodies, then this GM plays a very important role there. Okay. Now let us try to understand this. The case unstable, stable of this floating bodies, when it will be stable, when it will be unstable, like this. Okay. Now here the condition for this stability and unstability is a little bit dissimilar from that submerged body. Now due to the generation of this, as soon as you are applying a disturbing force here, your body will start tilting. Okay, and it will tilt about a point which is like the metacenter. This is like the metacenter. So about this point, your body started tilting due to the disturbing of the disturbance in the on your floating body. Now what happens when this happens? So this comes, here comes that is your basically the here comes a theta for the small. We are adding this, that GM is with respect to this theta, because here a distance generate here. So this is also theta. So theta plays a role here actually. Okay. When theta will be negative, so in positive it will be like a stable condition. And the main point of this stability, when G is above the buoyant force. Now look at here, the initial for the case of this, the condition is this, that is Z is above and B is lower. Okay, sorry, not this, sorry, this one, that B is above and Z is lower for the stable case. This is for the stable case, for the submerged body. But now here, for the stability of floating body, it is just like reverse. Your G goes up and buoyancy goes down. To maintain the stability, this have to be maintained. Now what happens when this is not maintained? And M is always lies above this G. So you can say that when M is above this G, your body is in stable condition. Your body is in stable condition. This you have to maintain. If G and M lies at the same point, then it is called neutral position. Now let's talk what happens with the turning effect, like we have discussed in the submerged body. Okay, let us discuss here. When you are providing a disturbance, okay, your body starts tilting about this point. So look at here, when you will take the moment, it will give like this. Your buoyant is always applying a force here, which will try to make this object in the same position. But you are applying a force here. This force can be like the air. Okay. You can imagine that in the sea, when the ship goes for the sailing, okay, sometimes in a very high speed of air, like in the storm, this condition arises. Means this disturbing force, which is due to the generated due to the velocity of air, is very large, and due to which your body starts, your ship starts tilting. Okay, means which is also called the oscillation, because your body is rotate like this. It is like oscillation. It will goes up this side, then same position, then again it will goes for the another side. So this is like the oscillation. And the time of oscillation means this time of oscillation is also depends on GM, this distance. If you remember this, I think the time is like the time of oscillation is 2 pi root under, I think here is come like the GM actually, if I am not wrong. Okay, I am not getting the exact formula of this oscillation, but that GM here plays the role actually. Okay, in the oscillation, in the ship case, because your ship, if I will draw a diagram here like this, so this is like the ship. So try to understand what happens here. This is your longitudinal axis. Longitudinal. This is your transverse. This is your transverse. So your body either, okay, will rotate like here about the horizontal like this, I through this. So this is about the longitudinal. It is called rolling, and this is I think called pitching. This is called pitching. So it will like this, and in the longitudinal it will like this, okay. So these two phenomena generally observed in the ship actually, that is rolling and pitching, and in both the cases your body had to come in a stable condition, otherwise your ship may overturn and it may sink inside the sea. So that's why this concept is very important. Okay, that metacentric height during the designing of the ship. What will be your time of oscillations and like this the GM height, where this GM will goes maximum force which can resist, like all this, but that also depends on like this G. Okay, G means the gravity force, and accordingly the gravity force, the gravity point moves actually. If you will put more weight on the ship, your gravity point will go. If you are putting the more weight here, your gravity will slowly goes down like this. Means that gravity will move in the vertical position, which depends. Means it can move here, it can move here, it can move. That depends on what is the loading criteria. Means what is the load on your ship, and accordingly that GM, if the G is displacing, so obviously that distance GM may change, which is the metacentric height. Here you can understand, because we have already discussed the restoring torque. This is your restoring moment, and this is your this is the turning moment, and this is always you need to maintain this. One will goes here, which will turning, and the restoring should be moved in this direction, and it will happen only in this such situation when, in the case of floating, when M is above the G. As soon as GM comes to this, means like the below this GM, your this case means this is will be same, but your restoring will again move in this direction. Okay. And in this case, your ship may overturn. The concept is same, that is restoring and turning moment, as we have discussed. And that is maintained by these 2 points, that is Z and M. The only change in the phenomenon in the floating body is that this B changes their position. But again, what happens? These two generate a couple again. In this case also, the couple is generated. This is your new position. This is your G. So again, there is a couple. So couple effect generate in this case, or in the submerged and floating both the cases. And that depends. When your aim will come here, it will add in the overturning. And when your aim will here, it will oppose the turning moments. And that's why this is the reason your ships comes to the same positions. So this is called the rolling, this is called the pitching. And in both the condition, you will require these concepts. Okay, why? Here, in the case of metacentric height. So actually, during the designing, we have to find out this metacentric height, this. For designing the stable condition. If aim come here, okay, if this is the aim, then it is like the negative. In this case, here you can see we have a, let me erase this. Okay, we have a value of this theta here, this theta. So in this case, this theta is like negative. Here in this case, this theta is like positive. And accordingly, your GM will be like the positive and negative. So when it is positive, okay, G is lower than like this B. And when it comes like here, this will give you the negative like this case. Here, this is the relation, that is ZM, that is ZM is equal to BM minus BC. It can be positive and negative, that depends on the stability and instability. Okay, so here you can write like the positive and negative. And BM is denoted by I by V. So this is your BM. And the relation for the BM is this, that is moment of inertia. You can write down this, that is MI by volume. Now, as I told you that this body oscillates about the two axes, that is longitudinal and transverse. Now let us consider if you are taking this, that is B, and if you are taking this as the length. Now what is the BM? Let me erase this. If I asked, okay, now what is the moment of inertia? Sorry, axis. Who will answer? Hello students, am I audible?
Sir, please repeat your question.
Yes, sir.
What is the moment of inertia about this longitudinal axis? And this is the transverse axis. So what is the moment of inertia about the longitudinal axis? आप लोग मोमेंट ऑफ इनर्शिया पढ़े हो कि नहीं? हाँ या ना? इतना टाइम
Yes,
लगता है? इतना टाइम लगता है? And what is the moment of inertia about transverse axis? That T for transverse, this is your transverse axis, that vertical line, and horizontal is for longitude. And this is our dimension, L and B. Who will answer? L is the length, B is the width of the ship, any ship. कोई जानता ही नहीं है? किसी को पता है? हेलो, बच्चा आप लोग अभी अभी एग्जाम दिए हो ना?
सर mb स्क्वायर बाय 2
हैं?
mb स्क्वायर बाय 2
क्या
mb स्क्वायर
स्क्वायर?
4
क्या?
mb स्क्वायर बाय 8
MB LB square.
नो सर this distance
L, okay, let me write this. LB square by 8.
no sir
Yes.
mb square by 8
NB बोल रहा है LB.
m mass
I am asking for moment of area moment. यहाँ मैंने मास बोला ही नहीं, मैंने डायमेंशन दिया है, मैंने मास का जिक्र ही नहीं किया। तुम लोग सही सही में पढ़ा है? हाँ, ऐसे कैसे चलेगा? किसी को आता है? एनीवन? द मोमेंट ऑफ इनर्शिया अबाउट एनी एक्सिस फॉर्मूला तो बता दो, जस्ट सिंपल।
Sir, I get BL cube by 12.
LB cube by 12.
हाँ, कोई अभी सही बोल रहा, क्या बोला? फिर से बोलो।
Sir, LB cube by 12.
L
B cube by 12.
by 12 for this longitudinal.
Yes, sir.
अरे here
Sir, यहाँ BL cube by 12.
ये कौन बोल रहा है, नाम बताओ।
Sir, आशुतोष नोटियाल.
अरे तुम तो बता ही दोगे, मुझे पता है क्योंकि मैंने पढ़ाया है। मैं तो बाकी से जानना चाह रहा हूँ। अच्छा, मेरे को ईमानदारी से बताओ, आप पढ़े थे कि नहीं मोमेंट ऑफ इनर्शिया? जस्ट से यस और नो।
पढ़े थे सर।
फिर बता क्यों नहीं रहा? पढ़ा तो देखो, आशुतोष भी था, बता दिया। कुछ और प्रॉब्लम है तो वो भी बता सकते हो। वनिष्का मिश्रा, am I audible to you? Vaniska Misra. Okay, so she is absent today, Vaniska.
Yes, sir. Yes, sir. Yes, sir. Myself. I'm here, sir.
पढ़े थे मोमेंट ऑफ इनर्शिया?
Yes, sir. पढ़े थे.
तो फिर आप बता
इतना बताना है ना, ये बता रहे थे।
हाँ?
सर वो एक्चुअली थोड़ा सा सर
फॉर्मूला तो याद ही होता
ये
है।
होगा LB क्यूब बाई 12 एंड ट्रांसफर उसका होगा BL क्यूब बाई।
यार जो भी तुम लोग क्या किए हो, पता नहीं आप पढ़े क्यों नहीं बताते हो। ओके, ये अगर कोई एक डायग्राम है, मैं आपको बस शॉर्ट तरीका बता दे रहा हूँ फॉर दिस टाइप ऑफ केसेस। आपको चाहे याद रखना हो तो आप लोग रख लेना, इसके बाद नहीं रखना हो आपके ऊपर है। ओके, दिस इज योर हाइट h। ये दो एक्सिस होते हैं जिसके अलोंग हमें निकालना होता है। हाँ या ना बोलो जल्दी जल्दी, टाइम नहीं है, आप लेट करोगे।
Yes, sir.
ओके, जिस एक्सिस, अभी लेट अस सपोज दिस इज आवर एक्स एक्सिस, दिस इज आवर वाई एक्सिस, जो भी एक्सिस के अलोंग आपको निकालना है, ये जिसको काट रहा है, ये किसको काट रहा है? एच डायमेंशन को काट रहा कि नहीं?
Yes, sir.
तो ये
Yes, sir.
क्यूब चला जाएगा, इट विल बी क्यूब, और ये दूसरी जगह आ जाएगा। दैट इज सिंपल। इसमें आप वाई एक्सिस के अलोंग जब ये आ रही है तो किस डायमेंशन को काट रही है? विड्थ को काट रही है, बी
Yes,
को।
sir.
ये यहाँ चला जाएगा बी और यहाँ आ जाएगा एच। सिंपल तरीका है, अगली बार से याद रखना, ठीक है? जल्दी बताते नहीं है। चलो तो आगे पढ़े कि नहीं पढ़े आई डोंट नो, आप लोग फॉर्मूला याद रखना, ये बीच बीच में आते रहेगी, इसलिए बता रहा हूँ क्योंकि आपको इस चैप्टर में आपको मोमेंट ऑफ इनर्शिया का रोल है। अगर आपको नहीं आ रही है देन यू विल फेस प्रॉब्लम, दैट्स व्हाई आई वाज आस्किंग। ओके, सो दीज आर दी relation. Now you can find the complete derivation of this relation actually in the book. It's very easy. It depends on the concepts of couple and all the mathematical simplification. That's all. You can go, and there is another method, the experimental method, जिसको हम लोग लैब में करते भी हैं। ओके, हमारे पास एक्सपेरिमेंट्स भी है, इसकी डिवाइस भी है फॉर फाइंडिंग दिस। ओके, लाइक मेटासेंट्रिक हाइट दिस। So that is the experimental method. Here B is the volume which is displayed. So these are the conditions actually, while these are the cases, means this, where you will find this type of application like in the C. So look at here. your length of the ship, what was our motive to discuss? Look at this, length of the ship is always large. Am I correct?
Yes, sir.
Yes, sir.
Now, if length is large, now then moment of inertia of this BHQ, sorry, here let me take the L, na? It was L, na? Okay, so it was L. So for L here, look at the L, let me write here. So it means, look at here, it is in the cube, means this length is large and it is in cube. So you can simply understand that this moment of inertia is always larger in comparison to longitudinal, means transverse moment of inertia is larger in comparison to moment of inertia about longitudinal axis, and this is how the rolling occurs. Now it means if the moment of inertia is large here for the case of transverse axis, so it means that BMT is larger than BML. And if BML here is larger, then you can see if this BM is large, okay, then this gravity, this G, sorry, metacentric height, this height will be large because this is large. So that GM is large. So when GM is large, your ship will more stable in that. So you can understand now your ship is more stable about this axis, means like in the pitching, like here it happens pitching here, like pitching. But in the rolling, your ship may roll and can overturn easily because this GM is less in comparison to transverse axis. So this is the reason. Okay, means from this you can understand the what basically occurs there, the mathematical concepts. Now I have an example. You can go through this video actually. Is it visible, all of you?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
So try to understand by this the very practical application, this study video. Is it running there on your side?
Yes, sir.
Yes, sir.
Okay, then try to understand. Hello, I'm audible.
Yes, sir.
Yes, sir, you are.
समझ में
sir.
आ गई है?
Yes,
sir.
sir.
The complete picture of this today's topic, okay, by one video. Means this is the practical application actually that happens. And as I told you that the more metacentric height means the more stability. So you can understand that about this axis, this longitudinal, your BM is large, means the GM is large. So in this longitudinal axis, this phenomenon is also observed, and which is called the pitching, like this, when this happened. And when this happened, like this here, is called the rolling. So basically in this ship, we have to maintain this condition. Because ship always, you can, I think I think all of you have observed this, that the ship always try to sink in this rolling, means the rolling is dangerous for this ship actually. Means not for the ship, if you have the object like this, when the length is small, large in comparison to width. For such type of bodies, we have to maintain, means we have to be very careful about the rolling condition. And as I told you that GM is large, the stability is large. Okay, so it means that if you have a point here, okay, like that is M, this is GM, and if this distance is moving, that is Z, that is M, so means the stability of this will be large. And this is the condition, and based on this GM actually, the height of the ship, like the cargo ship and the war ship, the designing of this is based on this GM. And a condition comes when this M is lies to G. So this is also stable. This is also stable, but that stability decreases here. Stability decreases here. Okay.
Yes, sir.
Now I will take the attendance. If you have any query, then you can ask. Okay, one more thing here. Am I audible?
Yes, sir, you are.
Yes, sir.
There will be a quiz test maybe tomorrow of the first and this chapter. So is it okay for you?
Yes, sir.
Yes, sir.
Okay, so numerical will not come from this topic because we have not completed the numerical part. But yes, theoretical part may be added in this the tomorrow's quiz test. And yes, the syllabus will be this first and this. This second chapter is without the numerical. Okay. Now
Right.
one more.
Okay, sir.
Okay. Now one more thing I was to inform. I'm not getting actually. I forgot. Okay, let me take the attendance first. Okay, one more thing. This chapter, this static chapter is finished here. Now we will start the kinematic. Aviles is present, Abhishek Zangir is present, Abhishek Kumar is present, for Adarsh is present, Ajay Bharti is present, Ajit Singh is present, Akash Yadav is present, Amandeep, Amar Bhardwaj, Amit, Anand Zain, Aniket, अनिरुद्ध ओके ये तो ब्रांच चेंज कर लिया ना जी
Yes, sir.
ओके अंजलि मीना इज प्रेजेंट अंकित आनंद इज प्रेजेंट अर्चित इज प्रेजेंट अर्जुन भाटिया इज प्रेजेंट अर्शप्रीत इज प्रेजेंट आर्यन आशीष आशुतोष आशुतोष नॉट Asutosh Nautiyal upgraded. Atul Kumar is present. Ayush is present. Ayushi is present. Chaitanya? Okay. Present.
Yes, sir.
Charan. Okay, okay. Charan Kamaljit. Absent? Okay. David is present. Deep Nayan is present. Aniket.
Yes, sir. Present.
Okay. Now Dev Chopra is present. Devasis is present. Shatvik is present. Gagandeep present. Gaurav Gupta, Gitika, Gurmukh, Harijay Singh, Harish, Harneet is present. Hars Bajaj is present. Harshit absent. Hemant Joshi present. Himani present. Inayat absent. Ishu absent. Zevi Reddy absent. Karanveer is present. Sitish is present. Lakshya Harish absent. Lokesh is present. Manisha is present. Manshul is present. Danis Alam is present. Naman Gupta. No. Narendra Kumar present. Naresh
Excuse me, sir.
Rawat.
सर
Yes,
सर
Mohit.
आप मेरा नाम नहीं लिया.
तुम्हारा छूट गया नहीं, तुम्हारा बन गया है मोहित, लगा दिया मैंने.
ठीक है,
Navdeep
ओके.
is present. Nikhil, Neeraj Kumar Chandel. Neeraj absent. Nikhil present. Nikita Verma present. Nilesh is present. Nite, ये लड़का नहीं आता है क्या? नितेश, नितिन, मीना, ये एक दिन आया है. Nitesh Solanki is present. Om Shiv is present. Vinay Babu is absent. Prachi present. Pratibha present. Radha Mohan Raghavendra present. Rahul Kumar present. Rahul Kumawat present. Rajan is present. Ramanpreet present. Raminder Deep is present. Ratan is present. Rayan Ali Khushid ये भी नहीं आता. Rishabh Kumar is present. Rishabh Sharma is present. Sagar Rohan Verma. No. Sagar is present. Shahil is present. Saksham is present. Samir is present. Sandeep is present. Saurabh is present. Shalu is present. Shivam is present. Srushti Nayak is present. Harshita is present. Suresh is present. Suhani is present. Sukhbir is present. Sukhbir present. Sumesh Saini present. Shaina Sharma present. Tanya 102 is present. Tisa Jindal is present. Tushar